Hi everyone, this is Sonal here. Today I'll be discussing about auto scaling groups, specifically covering the life cycle hook. So this is very interesting feature which I come across. Life cycle hooks associated with any auto scaling group. For that matter, life cycle hooks can be associated with a lambda function as well. But today our focus would be on auto scaling group. So during this video, first half we'll talk about the theory part, wherein I'll be showing you the screenshots taken from the AWS console, wherein the one of the cases using this life cycle hook is described in detail. So just a very brief about why we actually need a life cycle hook. This actually solves a problem, not only debugging any of the complex real-time scenarios, but these real life cycle hooks makes very easy in case you want to debug anything during your deployment, during the development. So any kind of data which resides on EC2 instance, and we want to take it up, we want to dump it somewhere before actually instance is terminated, destroyed. So this is one of kind of activity which can be customized to any level depending on the requirement, depending upon the scenario. So right now today, what I'll be discussing about one of a scenario wherein EC2 file system data which is residing on Verilog mount, that will be tarred and will be shipped to S3. And once that is complete, and this shipment will be done using the SSM document. SSM document will be called by lambda function, and lambda function will be triggered by an CloudWatch event based on the lifecycle hook. So today, the life cycle hook, it comes in two categories, basically during the termination and during the launch. So scale in and scale out, basically. So we are targeting scale in. So whenever ASG terminates any EC2 instance, so we will create a hook on that part. Before termination, it goes into wait state. The default timeout for this wait state is 1 hour, but in my case I have kept it for a minute, which is 60 seconds. So this is definitely not my original idea. I have taken this from AWS samples GitHub repository. So very detailed, very self-explanatory log is there. I thought of showing it as a working example. So here is the scenario. So how we start this scenario is basically with creating an SNS topic. So SNS will be used to get the notification once the backup, which is basically your S3 backup, is completed. That should send a notification which based to the email which is configured with this SNS topic. So this is about the backup outcome name is the SNS which we'll be creating during the lab session. IAM role, there will be two roles which will be created, one for Lambda, one for EC2. EC2 will have two policies assigned. One is the AWS managed, which is EC2 role for SSM, pretty very standard. The second one is ASG backup policy, and this backup policy is actually, if you see, is giving an complete lifecycle action authority to SNS. That means it will publish, it will send across the details once this life cycle action is done. That means we are not triggering anything when the life cycle termination happens, but when it's get over, this sends ASG actually sends a notification that my work is complete, now go ahead, terminate the instance and free up the resources. And that's how this SNS will come into picture. And the second part is about this lambda. So lambda is again critical, but again, as you know, all these services from the console, they look like interconnected, but they all are very independent services. So here what we are doing is we are creating this lambda function. If you see, it's creating all this log groups, and log groups will actually create a stream, and this stream will be very useful when we want to do any kind of debugging. So it's like creating a trace file for every lambda execution. We'll see that more in the lab. The next component, which, so if you see, this lambda role has three policies assigned, and same now for the ASG. First, definitely the start point is your launch configuration. So now with the latest AWS, launch configuration is the latest thing. Earlier, launch templates was the one which we used to associate first with any ASG. So launch configuration is basically has where your AMID is defined, what will be the instance type, what role should be associated with the instance, EC2 instance when they come into picture, and all these. This is one user data script which what exactly is doing, because the AMID I have taken in this example doesn't have any inbuilt SSM agent. So manually this yum install will install the SSM agent, and it will start as well. And second is your ASG setup with LifecycleHook. So what, once your ASG is associated with the launch configuration, what we are doing, we are creating a lifecycle hook. And what we are, as you know, these there are two kind of transition. One is the launch, one is the terminate, and default timeout is 3600 second, which is 60 minutes. So here our trap is for instance terminate. As you see, ASG backup is the lifecycle hook name, and EC2 instance termination is the event which we have trapped. And once that is done, uh, we need S3 bucket where our backups will be parked, tar files will be parked. So this is demo ASG bucket. And as we move on, this is the SSM document. So SSM document is nothing here, but it's a set of commands that will be executed on your shell script, on your Linux prompt. So using this SSM agent, so what it does is SSM agents will actually help in getting this script, this document executed on your EC2 instance. So this is all about we are taking this region etc information from the metadata of this instance. Then there are these some variables, ASG name, lifecycle hook, that we have hard coded because we are very specific about what we want to trap. And once this is all processed, what it's doing is it will copy this instance.tar to this bucket, and this is the backup which we are taking for is the var log. This is the backup directory. And once this is done, it will send across this SNS publish, and ASG will say to auto scaling that my work is done and go ahead and terminate this instance. And this is the lambda function which will be called by the CloudWatch event. And it's very simple. What we are doing, we are importing these classes, and here logging.getLogger is basically which will help us in creating a very detailed debug log at the CloudWatch end. That's why when we created the lambda function, we associated some policies, and one of that actually allows this lambda function to create these log files in the CloudWatch. And this is the CloudWatch event. So this is how ASG will be associated with CloudWatch. So what we are doing, this is the event, this is it, event pattern we are doing. Definitely we are not scheduling anything, and based on this event pattern, service name that we are targeting now today is auto scaling, and it has two types, instance launch and terminate. So here we are not differentiating, but if you see in the pattern, what we are saying, whenever there is this EC2 instance terminate lifecycle action, please trigger. And what it will trigger, it will call that lab. So let's move on to lab session. This is the GitHub page which has very detailed information about the lifecycle hook which we'll be implementing during this session. So this is actually AWS samples GitHub repository. This has this readme file with all steps described in very detail, with very clarity. So for any confusion, please visit this page, because this is the only page, this is the only framework which is actually being used during my presentation. So let's move on. Set up the environment. CLI is very important. Basically, few of the commands will be executed using the CLI. Few of them will be done using the console. So as you see, step one says create an SNS topics, and that would need, although we can do it using the console as well, but it's good to have both CLI as well as console to get understanding what is the difference. There is a whole lot of difference. That's not the scope of this presentation, but yes, you will understand there are many things which are auto done on the console, whereas if you move on to CLI, everything needs to be done stepwise. So first step would be to configure CLI. So by configuring CLI, what I am doing is basically I am associating my this session with uh, my console credentials. So command is configure, AWS configure. Already a key ID, access ID, my default reason is UST is 1, so nothing is needed here. We are sorted. Let's go and execute the first command. Backup 1 already exists, so I am moving ahead with backup 1 as an SNS topic. And if we go back to SNS page, this topic we'll see as the listed one. Go to topics here. So this is done. And the second step would be we associate an email ID or a DG group with this SNS, so that in case SNS has anything to send, it will send across that to this email ID. Now the second part is creating the IAM policy and the IAM role. I have already done that. We'll briefly go through what exactly this step is doing. So what we are doing here is, this is the policy name, ASG backup policy, and this backup policy is on action whenever the auto scaling is doing this complete lifecycle action. It will SNS will publish the message to the subscribed email ID. And what does this complete lifecycle action means here is that auto scaling group has this feature to hold instances before they actually go out of service and before they come into service. So basically there is a timeout which occurs during scale in and scale out event. So because we are trapping here the instance termination, default timeout is around 60 minutes. We won't wait for that long. Once our life cycle hook related activity is done, manually we will tell auto scaling to signal that my work is complete and go ahead with the instance termination. So this is what this policy is doing. So here on IAM console, if you see, these policies are already exist. This is the ASG backup policy. Then I created the role and assigned these to these roles. So there are two roles which are being created here. One is the instance role. So any role which we associate with any EC2, it's more than a role, it's like a container. But for time being, let's understand instance role is a role, and to this instance role these policies are associated. So one is the ECT role for SSM and ASG backup policy, and the difference is one is customer managed and one is AWS managed. The other role which is being created here is the Lambda role, and Lambda role gives actually the privileges to Lambda execution, Lambda function, and the policies assigned are again Lambda execution role, full access. SSM full access, if you see, is the common on EC2. Basically we will be deploying the SSM agent, and those SSM agent will actually execute the SSM documents. So the purpose of assigning this policy is to manage SSM agents and our work using these SSM agents. Lambda basic function, what we are targeting here is we want to create a logs, because we will enable the trace, we will enable the logging in a debug mode, and what that log event will do, it will generate very detailed trace kind of log, which will tell us how exactly the lambda execution worked. And this helps, especially for the newcomers, it becomes very easy to understand how this lambda execution actually works, how individual services interact with each other. It's not that straightforward, although it looks like all services are on same console so they can actually communicate, but it's not like that. There are whole lot of steps which goes between the endpoint communications. As we move on, this auto scaling group will be created, but before creating the auto scaling group we would require a configuration, launch configuration. So there are two ways of doing it. One, you associate your ASG auto scaling group with launch configuration or launch template. So launch configuration, just a very brief about it, is the latest, which gives you the flexibility of adding multiple type of instances, meaning you can have this spot instances, reserved instances, uh, on demand instances. They can actually be, accumulated in one configuration. So that is the launch configuration, but template used to support only one kind of instances. There are many other differences, this is one of it. So as we configure this launch configuration, there is nothing which is done. Only point to be noted here is that this is the AMI ID which I am referring to, then the key pair, and this is the instance profile. If you see, we created this instance role in the last step, so particularly this instance will be associated with all the instances which are being launched using this launch configuration. And then there is one, this user data. What we are doing here is we are installing SSM agent and we are starting them. So this is the customized task which we are doing, because this AMI which I have chosen doesn't have the SSM inbuilt. There are AMIs which are available, so which actually have all these agents, and there are multi yum stores which come inbuilt, so we don't need to do this step. For now, move on to next. Now we'll create this ASG backup configuration and we will associate it with this launch configuration. So this is my ASG backup scaling group. What I did was I used, because that's the mandatory step, you have to associate an scaling group either with launch configuration or with launch template. So what I did was I associated it, and if you see in the definition here, this is the launch backup configuration which is used by this ASG. And as we see the details, minimum capacity it's 0 here right now because no instances are live right now. So let's go ahead and edit it so that we will have some instances to work on later. So let me make this as 2. And what I am doing here, if you see, because I selected this launch configuration copy as a source for this ASG, automatically it's showing the AMID which will be used, instance type, etc. These are the subnets, and then as we move on we'll update it. So this is done. So this step is complete. And what we did manually was we created this LifecycleHook with ASG, meaning we want to have a LifecycleHook trapped. By default, none of the LifecycleHooks are do anything. If we go to instance management, here you see this is the LifecycleHook and this is the EC2 lifecycle terminating hook. If I create on create, here how we configure it, we define the hook name, and there are two type of transitions which can be trapped. One is the instance launch, one is the terminate, and default, if you see, the timeout window is 60 minutes. And what would be the action, and if any notification needs to be sent. So what we did here, we did nothing, we just created this instance terminated is this heartbeat timeout to 60 seconds and a name. So what it does is it will wait for 60 seconds before taking any action, before actually removing this EC2 from the service. And next is to create an S3 bucket. So it's always advised to create the S3 bucket in your region, which is closer. Otherwise, there is no foundation. S3 is a global resource, but the region in which you are working on, get it created there, it will be faster. Then comes your SSM document. So SSM documents basically has this script which you see is not doing much. What we are doing here is we define these variables. Our backup directory is var log, and we this instance ID is doing the curl on this metadata. This is AWS provided metadata link. So we are retrieving this instance ID from this HTTP address, then the region, and once that information is available, this particular uh, target, what it's doing is it's creating because you may wonder, SSM is already there on that account, why would need an instance ID? That's because we want to have the instant ID used in our tar file. So tar will create this tar file, and once that's done, it will copy it to S3 bucket, and SNS will publish that backup is complete with all the details, and auto scaling will signal to LifecycleHook that don't need to wait for a minute, I am done in 30 seconds, then let's move ahead. So this is the documents page. Okay, so these are the steps, and these are few of the things which we need to change. If ASG is not created by ASG backup name, then this needs to be changed. Same goes for LifecycleHook backup directory. If any particular directory which needs to be backed up, tar file bucket name, if the same name is not followed, and the target, of course this will change. It will depend on your account ID and your topic name. Okay, so I go here, owned by me. This is my ASG log backup, and these are the contents of my SSM document. So these are all the detailed one which we already saw here. And as we move on, let's move on to the Lambda page. So what this Lambda is done here, these are the very basic steps. It's creating Lambda function. And what Lambda function is doing, basically Lambda function is calling this SSM document. And why we are doing it using the Lambda function? Because we want it to be triggered based on a particular event. We don't want SSM agents to call that every 10 minutes, 15 minutes. That's not the requirement here. So you see this logger, what we are doing for any activity, for any execution, any work Lambda is doing, we want to see how exactly it went. So that's why we created that SSM role. We created the policy for Lambda specifically to create logs in CloudWatch. And here life cycle, again these are hard coded values because we are very sure what we want to trap, what life cycle hook, what ASG group, and based on that what this Lambda is doing, it's actually these are some of the context things which I got printed. I'll show you when we actually execute this entire and how this will help. So what it's doing is it's actually reading all the information from the context from where this is being executed, and based on that actually it finds out what's the instant ID hook, and once that is found, it finds out based on that the document which is applicable, the SSM document which is applicable on this particular execution. And what it will do, it will execute the document. See here, check document command ID instance ID. So it will SSM document will be executed using this Lambda. And same, let's move on to this CloudWatch, as this steps describe about the CloudWatch event. So what we are doing here is we are trapping this EC2 instance lifecycle action for ASG. So this is already been configured here. If we go to rules, to CloudWatch event, so this is the rule which I configured. So what it does is it says for auto scaling group, if this is the action, then call up Lambda. Filter target is my Lambda event, which is Lambda backup. Now test the environment. This is the best part. So let's move on to EC2 and see how this whole entire setup actually looks like when we execute it. So if you see, I just updated the auto scaling group to have two EC2 instances. They are up, they are running fine. If I connect to any of these instances, here I am. If we go to this var log folder, all these files are there. So probably what I could do, I can do some touch sonal.txt. This is my test file from EC2. Okay, so this is done, and if we see the host name, let me note down this instance ID. We will see it later on how this during the termination. So these are my two instances which are running right now. Let's move on to ASG. So as you see here, what one of the test scenarios is you change the minimum of two instances defined here in ASG, and what this test, one of the test scenarios says is reduce the minimum capacity to 0. So what will happen once we do that, our instance will be terminated, and once the termination start, they will definitely go to lifecycle hook termination transition, and that will create actually a Lambda output in the CloudWatch, and S3 will have the backup created. So let's go and do this. So I move on, I make this as desired capacity as 0. So this is updated, and let's see in the activity tab what's exactly happening at the ASG end. Here you see this is showing the launching which actually happened, I think, yesterday, and if I refresh it, this has started terminating my instances. Okay, let's move on to CloudWatch, if any of the logs generated so far, and I'll open S3 as well in, and here we go to our log groups. This is my Lambda backup log group which I created, and if you see these still are dated 7th 8:37, so this is the latest one, and let's see if it's showing any instance ID. See, this is the benefit of having this enabled, log enabled. So if you see, all the messages are printed here. This is showing that the Lambda function has used 128 MB of memory. It took 1998 milliseconds to execute. These are the additional variables I am getting printed because I was debugging and it was failing at some point. So I just wanted to see how the backup values are coming in, how the conditions are evaluated. So the instance ID covered here is this 88E. Ours is a different one. Okay, doesn't matter because the only difference would be the tar file. So this particular instance ID tar should have sonal.txt as well. So as you see, this lambda execution had so much to capture, so much to communicate, everything. So it's look like this has completed successfully, no try needed, everything is completed. And I think same thing goes for the other execution as well. And this is showing two entries because this is moving instance wise. Yeah. So here, this is my instance ID 4B93. See, this is my instance ID. Okay, so let's move on to S3 and see if we may go see if any of the instances are still online or they are terminated. See, no instances found, so nothing is running here. If we go to S3 to my demo bucket, these folders have been created. This is the latest 87. Instance ID is 260, but what we are looking for is 4B93. It's here 4B93837. Let's see the contents of this star. It won't show me here. So what I have to do is I have to download this star folder. Here, see, this is my files. And as the EC2 terminated my instances, my CloudWatch event, Lambda function, SSM document, SNS, all orchestrated well. So this is the end of this test environment and the implementation of this AWS Lambda lifecycle hooks function. Hope you like it.